All right, so today we're going to get back into our linear functions and specifically getting back, not back, but starting to write the equations of our linear functions. We were graphing them before, and so now we want to be able to take some information that we know about them and come up with the equations ourselves. Okay? So the point behind today is to be able to write some linear equations when we know the slope and some point on the graph, right? So, first thing, quick review. You got two functions here. We want to be able to identify the slope and the y-intercept, right? So can you do that? First equation, the slope is going to be 1, right? And the y-intercept is 9. So this is slope-intercept form, and that's what we're looking at. We're looking at slope and the y-intercept. Second equation, the slope is negative 3/5, right? And the y-intercept is, 0. So if you don't see the y-intercept, it's supposed to be a constant out there. We know it's got to be a 0. If you don't see a number written as the slope, or if you don't see a number as a coefficient on that x, then you know that number is actually a 1. So there's a difference for when those numbers are missing. Now, take a look at these two functions, right? If I were to graph those lines, what would be different about those two lines? Right? Well, first of all, they've got different slopes. And they've got different y-intercepts. Both. The slopes and the y-intercepts are both different. So then they're obviously going to be two different lines. Well, even if in this second equation I gave it the same y-intercept as the first, gave it a plus 9, these two lines would still be different because they have different slopes. And even if I took that 9 away and gave the first function the same slope as the second one, they would still be two different lines because their y-intercepts are the same. And so what I'm getting at is having different slopes would make two lines different. Having different y-intercepts would make two lines different. As a matter of fact, y-intercepts are nothing more than a fancy point. So if two lines go through different points, then we know they're going to be, if two lines go through different points, we know those two lines are going to be different, right? So what I'm getting at is there are two characteristics that separate one line from another. And those two characteristics are the slope and a point that they go through, right? So in order to write the equation of a line, write the equation of a specific line, I would need to know that line's slope and a point that it goes through so that I would know that I'm writing an equation for a line that's different than any other line, right? So you got to have a slope and a point to write the equation of a line. Now, if that point were a y-intercept, life would be easier. So I'm going to write in y-intercept would be nice. Right? We'll talk about y in just a second. It doesn't have to be, the point that we know doesn't have to be a y-intercept, but that would be really, really nice. All right. So if we're going to get into writing equations of a line, then we have to know the slope. And so we may have to go figure that out. So we're going to have to remember the slope formula, which says that we're going to subtract the y's in the numerator and subtract the x's in the denominator. Right? So that's your slope formula. We do want to remember slope-intercept form because, like I said, if we know the slope and the y-intercept of a particular line, then we can just plug in the slope there and plug in the y-intercept there, and we would have our equation of our line. We'd be done. Okay? But the y-intercept is nothing more than a fancy point, so we know that all we really need is a slope and a point. Well, if the point that we know that is on the line, or the point that we know that the line goes through is not the y-intercept, then we cannot use this form. That's not going to help us. So another form of this of a linear function was developed to help us be able to write an equation when we just know a point and not the y-intercept. And that's this guy. This is your point-slope form, right? So it's quite cleverly named point-slope form, right? Now I say that kind of jokingly because we're going to use the point-slope form to write the equation of the line when we know a point on that line and we know the slope. Okay? if that point is a y-intercept, we could still use this form, and maybe we'll talk about how when that happens. But if that point that we know is a y-intercept, I would go back to slope-intercept form and just use that. Okay? So, there's your point-slope form, and you're going to have to remember that. Now, I also want you to pay attention to the fact that every linear function that you will ever see, so the two examples that we had previously, where we're picking out the slope and the y-intercept, they look like this, right? But if you go back and look at every linear function that we've had, every line that we've graphed, everything that we've developed before, every one of those functions have a plane y and a plane x in it, okay? That x and that y are reserved for us to be able to put any point on that line in those two spots, the coordinates into those two spots, if that makes any sense, right? But bottom line is, every time we write the equation of a line, we have to have a plane x and a plane y in there. I say that because that means to us that we never want to plug in anything for this y and this x. These have to stay in the equation, okay? Everything else, the y1, the m, and the x1, we're going to plug numbers in for. And we're going to get that from our slope and our point, okay? So, for example, if we know that the slope of a line is 3, and that line goes through the point 2, 5, we want to come up with the equation of that line. And we want to come up with the point slope form and the slope intercept form, right? All right. Well, since we know the slope and we know the point, the two things that we have to know, we're going to use the point slope form to write the equation of the line. So y minus y1 equals m times x minus x1. Right? And so we're going to plug in 3 for the m. And then, yes, this 2 is the x-coordinate for this point, and this 5 is the y-coordinate, right? But I've already said we are not going to plug anything in for that plane y and that plane x. So that means that the 5 must go in there for the y1. So we're going to go y minus 5. And then the 2 must go in there for that x1. So then we go x minus 2. And there is the equation of that line in point-slope form. Now, the directions also ask it for slope-intercept form, so we're not done. We've got to change this around. Remember that slope-intercept form is getting y by itself. Y equals mx plus b. So we got to take this guy and work on getting y by itself. Okay? Well, that means simplify the function down to where y is all by itself on one side. So the first thing we want to do is what we always want to do when we have a number outside of parentheses, and that's distribute it. So distribute that slope. 3 times x is 3x, and 3 times negative 2 is negative 6. And then to continue getting y by itself, we're just going to add 5. So it's actually just 2 more steps. It's not a whole lot more work to get this in the slope-intercept form. Just distribute the slope and then add or subtract over whatever the y-coordinate was, and you're done. Okay? That's it. Okay? And things only get a little bit more complicated as we start doing things like this, and that's throwing fractions at you. Okay? Just take a look at this guy really quick. Right? So you'll hear me say this a lot, right? What 2 things do we have to know to write the equation of a line? We have to know a slope, and we have to know the point, a point that it goes through. Doesn't have to be the y-intercept. Be great if it was, but it doesn't have to be. So we've got the slope and a point here, so we're just going to use point-slope form to write the equation. Right? So we're going to put negative 1/3 in for the m. Negative 4 goes in for the y1. So make sure you put the minus and the negative in there. So that is going to flip-flop the sign, right? So this becomes y plus 4. And then that's point slope form, but we've got to put it in slope-intercept form. So we are going to have to distribute. So distribute that negative 1/3. And that's going to be a little bit tough for us because we don't like fractions very much, but negative 1/3 times x is negative 1/3 x, so it's not too tough. And then negative 1/3 times negative 3. Well, all you got to do is take the numerator times this guy and then divide by the denominator. So negative 1 times negative 3 is positive 3, and then positive 3 divided by 3 is positive 1. So not as tough as it looked, Now we're just going to subtract 4 from both sides. And we get y equals negative 1/3 x minus 3. And there you go. Okay? Make enough sense? So a little bit of fraction work involved, but still hopefully not too terribly difficult. You're just distributing that slope and adding or subtracting over the y coordinate. Okay? All right. Next one. Maybe the slope, being a fraction, won't always multiply out like that for the... And so if it doesn't, we've got to do a little bit more fraction work. So got to have a point and a slope. We have a point and a slope, so we can put this guy into point-slope form. So I'm going to go y minus, if it helps to label this, do that. So y minus 2 is equal to, so we got to go 3/4 times x minus a negative 1 makes this x plus 1. Right? All right, and then so that's point-slope form. To get it in slope-intercept form, we got to distribute here. So we go y minus 2 equals 3/4 x plus 3/4. Right? Because 3/4 times 1 is 3/4. No problem. No reason why that can't be 3/4. There is a 3/4 on the y-axis if that is indeed your y-intercept. So now, we've got to add the 2 over. Which means now we've got to add a whole number to a fraction. Right? But we can do that, right? Just got to make this guy have a common denominator. Right now it has a denominator of 1, needs to have a denominator of 4. So multiply this by 4 in the numerator and the denominator. And so this guy actually turns into 8 over 4. So now we're going to add 3/4 to 8 over 4. And so we get y equals 3/4 x plus 3 plus 8 is 11. So 11 over 4. Okay? So a little bit more complicated when you have a fraction as a slope, but we can still do this. Right? All right. What if your slope is something kind of weird like 0? Well, we can still do this the same way. We have a slope, we have a point, so we can plug this into point-slope form. So I'll go y minus a negative 8 makes this y plus 8, and then 0 for the slope, x minus 7. Watch what happens. 0 times this stuff is just going to give you 0, right? So y plus 8 equals 0. And then when you subtract 8 from both sides, you get y equals negative 8. Right? So, great. You've got your equation. Y's by itself. But your life could have been a lot easier if you can just stop and think, right? But I know on a quiz or a test, you're going to get going. You're going to do the first 2 or 3 problems with point-slope form, and you're going to want to do all of them with using point-slope form. You're going to see in a second why that's going to be a bit problematic. So just think about this. What kind of line has a slope of 0? And hopefully you're thinking about a horizontal line, right? Because of hoi, H for horizontal, the O tells you that the slope is 0. Well, hoi also tells you that the equation of that line is y equals wherever it hits on the y-axis. Well, if it goes through, if the line, horizontal line, goes through that point, what point is it going to hit on the horizontal, what point is it going to hit on the y-axis? Well, if we plot negative 7, or sorry, 7 comma negative 8, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, then we would get a point about right here, and then a horizontal line would just go through the y-axis at negative 8. So it's just going to go through the y-axis at wherever that y-coordinate is. So we could have stopped and just said, hey, you know what? The equation of that line is going to be y equals negative 8. So what that means, there's a whole bunch of writing here, but what that means is that if your slope is 0 and you want to write the equation of a line, you don't need anything else except that. Y equals negative 8. So save yourself some work and think about what's going on first. If the slope is 0, it's going to be a horizontal line, which means the equation has to be y equals wherever it's going to hit on the y-axis, which is just going to be the y-coordinate negative 8. Okay? And the reason why I bring up just thinking about this for a second is because what happens if our slope is undefined? If you're going to use the point-slope form, because we have a point and a slope, y minus 0 equals undefined times x minus 3. Well, how the heck do you distribute undefined? That doesn't make any sense. So instead, don't do this. Stop and think. What kind of line has an undefined slope? Well, the other funky word, vux, that we keep using, U stands for undefined. It's going to be a vertical line, and the equation is going to be x equals wherever it hits on the x-axis, and that's just going to be whatever this x-coordinate is. So your equation is just going to be x equals 3, which, oh, by the way, this is the x-intercept, so that makes enough sense. Right? So kind of stop and use your brain for a second, right? And if you do, it'll save you a lot of work, especially work that you're not going to know what to do with because it just looks weird. All right? So x equals 3. All right. So a couple of those examples. Got one more here for you. Go ahead and stop the video for a second. Come up with your slope-intercept point-slope form, and then you can start back up and see if you've done it correctly. All right, so did you get that? Y plus 5 equals 1 times x plus 4 is going to be your point-slope form. Remember that we're making those pluses, y plus 5 and x plus 4, because the negative 4, the two coordinates are negative, x and the y, right? And then when you distribute and then subtract the 5 over, you should get y equals x minus 1. That's it. Piece of cake, right? All right. Sometimes linear functions are presented to us in tables. And even with the table, we need to still be able to come up with the equation of that line. So we just keep thinking the same thing to ourselves over and over and over again, and that is, what two things do I have to write the equation of a line? I got to have a slope, and I've got to have a point that is on that line, right? So my first question is, do you know the slope of this line? Just looking at this table. And hopefully you're saying, well, no, I don't have the slope. Okay. Do you know a point on this line? And as a matter of fact, you don't just know a point on this line, you know 5 of them. So we got lots of points, just not a slope. So can you find the slope though? Well, yeah, right? All we have to do is take 2 points, like say that one, and I don't know, that one, and use the slope formula, right? That slope formula that says, to find the slope, just subtract the y's over subtract the x's, and we should be in good shape. Now, I chose those 2 points. Does it matter which 2 points you choose? Yes, that question is no, it doesn't. Because a line is straight, it means the slope all the way up and down that line is going to be the same. So you can choose any 2 points you want, and you should still get the same slope. So I'm going to choose those 2, and we'll go from there. All right, so to find the slope, subtract the y's. So I've got to go negative 2 minus 2. And if I go that way, I have to go negative 2 minus 0, which would give me negative 4 over negative 2, which would give me 2. So the slope of this line is 2. Now, I need a point and a slope. I've got a slope. I've got lots of points. Just choose one of those points and get back into your point-slope form. I'm going to choose a different one just for fun. Again, it doesn't matter which one you choose. So I'm going to go y minus 6 equals 2 times x minus 2. And since it just asked for the equation of a line, you can stop there. It didn't ask for slope-intercept form, right? So you can stop there. I wouldn't go any further. If you try to go further, then you run the risk of making a small mistake. So just stop right there, okay? And that's it. Homework's out in Canvas. Make sure you have that done by next time.